Welcome to The Explainer. Today, we're cutting straight through all the AI hype and looking at how tech giants actually build machine learning products in the real world. We're diving directly into Google's own internal playbook, specifically Martin Zinkovich's famous rules of machine learning. So if you want to know what it literally takes to deploy systems used by billions of people, well, you're in exactly the right place.
And we're going to start with this quote from Zinkovich. The key to building a great machine learning system is to be a great engineer. Boom. That right there shatters the illusion of machine learning as some sort of magic wand that just automatically fixes all your business problems. Our core thesis today is that before you can be an ML wizard, your engineering fundamentals absolutely must come first.
Here's how we're breaking it down today. We'll start with the engineering reality, move into phase 1 with the first pipeline, look at defining the right objective, and then phase 2, feature engineering. After that, we'll tackle avoiding training serving skew and wrap up with phase 3, complex models. Okay, let's dive into this. Part 1. The engineering reality. Fundamentals before magic. Rule number 1 of Google's playbook is actually incredibly surprising. It basically says, do not be afraid to launch a product without machine learning. Right? If you don't have data yet, just don't use ML. It's totally fine to launch with simple heuristics, like, ranking apps by install rate or just sorting contacts alphabetically. You literally need a product out there in the wild to gather the data your future models are going to learn from. But as you gather that data, you hit a crossroads. On one hand, you have complex heuristics, these massive tangled webs of handwritten if-then rules that eventually become a total nightmare to maintain. On the other hand, you have formal machine learning. Think of machine learning kind of like a compiler. A compiler takes your code, looks at the target operating system, and spits out an executable file. While ML takes your historical data and your objectives and spits out executable policies. Once you've got enough data and engineering resources, machine learning absolutely crushes complex handcrafted rules.
Which brings us to phase 1, the first pipeline. Keep it simple. When you finally make that transition to ML, your absolute top priority is not writing some insanely complex, cutting-edge math. It's just getting the infrastructure working and making sure it's robust.
Just look at these initial steps. What's really interesting here is how grounded and remarkably basic they are. Step 1, make the pipeline solid end-to-end. Step 2, pick a reasonable objective. Step 3, add common sense features simply. And Step 4, keep that pipeline solid. Seriously, a massive chunk of your time is just going to be spent gathering data and applying the model. A super basic model will almost always give you an initial performance lift. And keeping things simple makes it so much easier to hunt down pesky infrastructure bugs. Which leads us to a very, very practical question. Is there anyone here who likes getting bad news at 2 a.m.? I'm guessing that's a hard no. Well, if you don't want that middle-of-the-night wake-up call, Rule 9 was written exactly for you. Rule 9 is all about sanity checks, detecting problems before you export your models to production. Look, if your model breaks during the learning phase, your engineer just gets an email. No big deal. But if you export a broken model to live users, your on-call engineer is getting paged to 2 a.m. You absolutely need sanity checks. Check the file size of the model so it doesn't just nuke your servers. Check its performance on held-out data. You basically have to build a brick wall between your algorithmic genius and your livelihood.
And you've got to watch out for silent failures. Consider the number 6. At one point over at Google Play, a data table just stopped updating. And it went completely unnoticed for 6 whole months. Why? Because the machine learning system just quietly adjusted around it and gradually decayed. No alarms, nothing. When they finally found that stale table and just refreshed it, they got a massive 2% boost in their install rate. So monitor your infrastructure.
Okay, so once your infrastructure is solid, we hit section 3, defining the right objective. What are we optimizing? The crucial point early on is you really need to keep this simple.
Whatever you do not overthink your very first objective. Trying to mathematically define some abstract concept like user happiness or overall company health is practically impossible early on. Instead, pick an objective that is directly observable and can be attributed to your system's action. Did the user click the link? Did they download the app? Did they forward that email? These are simple, measurable proxies for your true objectives. If your clicks and downloads are going up, well, your long-term metrics are usually going up too.
It's only after you have a working end-to-end system that you enter phase 2, feature engineering, adding complexity. Now we're talking. This is where all the low-hanging fruit lives, where you start pulling in intuitive data points to actually make your model smarter.
The hands-down best way to create new features is to just look for patterns in what your current model gets wrong. Like, imagine a user searches Google Play for free games, and the system ranks this totally useless gag app right at the top. You might immediately think, oh, I'll just create a feature to identify gag apps, but hold on a second. If your system is currently optimizing for installs and users are actually clicking and installing that gag app as a joke, the algorithm is just going to keep promoting it because, hey, it's hitting the objective. You have to quantify these undesirable behaviors first, maybe get human raters to flag gag apps so you can properly penalize them before you try to just optimize them away. Measure first, optimize second.
All right, let's move to Section 5, Avoiding Training Serving Skew, the messy reality. As your features start getting more complex, you are inevitably going to run headfirst into one of the most notorious pitfalls in all of machine learning.
It's called training serving skew. This is basically when your model performs beautifully in your offline training environment, but then just completely degrades when it's live in front of real users. Why does this happen? Well, the data your model looks at during batch processing training is subtly different from the real-time data it sees during live serving. Maybe a database table updated in the background, which fundamentally changes the features between the time you train the model and the time you actually served it. It's a mess.
So what's the fix? The ultimate fix for this skew is to log your features at the exact moment of serving. Do not try to reconstruct what the user saw later on. You actually need to save a log of the exact data the model used to make its judgment in real time, and pipe that log data straight back into your training pipeline. When the YouTube homepage team switched to this exact method, they saw massive quality improvements and a huge reduction in code complexity. The rule here is simple: train exactly like you serve.
And eventually, you'll hit phase 3, complex models, the plateau. At this point, the simple tricks just stop working. The low-hanging fruit? It's gone. Your monthly gains start to diminish, and you enter this new phase where you really have to rely on complex models and start dealing with some highly complex trade-offs.
Imagine this scenario. It brilliantly illustrates the exact kind of conflict you're going to face in phase 3. Think about how experiment A compares to experiment B. In A, you've got 1 million daily active users generating $4 million. Great. But in B, you double the users but cut the revenue in half. Now think about it. If your current live system is A, your team is not going to want to switch to B and lose all that revenue. But if your current system is B, your team definitely won't want to switch to A and lose half your user base.
When metrics conflict like this, you suddenly realize there are no simple hit points for your product's overall health. You can't just maximize one single number anymore. Metrics in an A/B test are really just proxies for your ultimate goal, having a thriving, profitable company 5 years down the line. So, if a simple heuristic beats a complex machine learning algorithm across these conflicting metrics, you should absolutely, for sure, choose the simple heuristic.
Which brings us full circle to this really powerful realization from Martin Zinkovich. He points out that the future of machine learning isn't just about infinitely more complex models predicting clicks. It's actually about figuring out how humans and machines can work together to determine how to best reach our long-term goals, right? The human element, the engineering, the objective setting, the product vision, that is what actually drives the whole system forward. So as you look at your own projects and dive into your own data, I want to leave you with this final question. Are you going to chase the hype and magic of complex algorithms? Or will you build solid, heavily engineered systems that actually withstand the test of time? The choice is absolutely yours, but the playbook is clear. Thanks so much for joining me on this explainer. I highly encourage you to go check out all 43 rules in the source material. Catch you next time.